Dear students, welcome back. In today's class, we'll learn about fluctuating loads and how does fluctuating loads work in practical scenarios. Here we'll learn about actually what is load and how load works. This is not a one-day class. This will be continued in 2-day class, 2 sessions or 3 sessions, because to understand the fluctuating load, it's a bit tricky thing but easiest thing, but because it deals with practical world problems. So let us start. So what is fluctuating load? At first we need to understand this. What is fluctuating loads? To understand in a simpler way, let us go to a blank screen and we have to understand this. Let us consider a body. A force is acting F on this body, okay, and the body is fixed over here. What happens? There will be a change. If it's an elastic body, the thickness of the body will change by some bit, or that means there's maybe some deformations. In short, there may be some sort of deformation, but it is practically possible for your stationary bodies, the bodies which are not in a motion. But does in practical world everything is in stationary motion? Is it everyone is in stationary? No, it's not. In everything is not in stationary. Most of the things are in a motion. So that means this scenario can be enacted in this way also. If you consider this is a rolling, there are 2 wheels applied over here and a force is applied over here. What will happen? This body will move forward. Now what comes? There is the most important problem. What can be the problem over here and what can be the problem over here? This is static fluctuations, static loading. Static loading doesn't have fluctuating objects. But when it's a loading at motion, that means it will have some fluctuating problems. For example, the wheel shaft may go wrong, may break up, or there may be the crack may propagate. So there are numerous number of examples which are being shown in your slide. As you can see, let us go to the slide. Okay, let us go to the slide. Now as you can see, as per the history proves over there, in 1982, May 1982, there was a train crash in Paris due to the axle of the locomotive, that is the engine part, broke down. Now if you come down, you could see a heavily land crash, that is an aircraft named as Comet. It broke up in a meteor. Why? Because every part is completely moving. That means there will be some sort of vibration related to your fluctuation. What happens? Is it broke up. Like Aloha Airlines accident, the most famous aircraft, that is Boeing 737-200, which went down, which broke down in 1988. The number of people who lost their life was 1, but the injuries was 65. So the thing is that it is nothing but everything. The most of the mechanical incident happens only due to your fluctuating stress. This is one of the most popular of thing. Now you can see that the aircraft fuselage, that is, people are coming from the aircraft in this way. That means what happened is the one of the passenger, this is the actual story what I am explaining you, what a fluctuating stress can do. A passenger, while boarding the aircraft, saw there was a hair like a crack on the body of aircraft. that was neglected by those airlines officials and everything. What happened, while the aircraft was traveling at a speed of 500 kilometers per hour, like per hour speed. So what happened is, this complete fuselage, that is the complete aircraft covering, came or ripped off. Why? Because the crack on the body got increased due to the fluctuation of the stresses. Hence, you can understand how much a fluctuation stress of stress could work to a fatigue. So that means if a hair-like crack of 1 centimeter can be disastrous for machines like this. So we have to understand how it happens and what it can be. Now this is the last thing what I am showing you. After that we will be going back to our work. This is a fuselage of an aircraft. That is the blue part. What you are seeing, that fuselage of an aircraft, which is subjected to a stress. In the first picture you can see that there are opposite arrows direction. So what happens is, there is a contraction and releasing. When the aircraft goes up, goes at the higher altitude, there is a contraction and releasing. That means there is as well as there is a motion. So everything related to a cyclic loading. Why its name is cyclic loading? That is nothing but your fluctuating loading. That is, the load is not constant, like the load what we can see in your. Let us go back to our as you can see in our static stress or static body, like when a body is subjected to a single force or double force. So you can understand that double force and single force is just a concept that you have studied in strength of materials in your previous semester. That is completely a concept. That's not the practical thing. This part is your practical thing, where it's working. Now coming back to the main thing. This is as you can see, this is a rod. While it is rotating clockwise, there is one the rod, while rotating at high RPM, the rod gets deflected. That means the rod turns to, it gets in the shape of bow or a curve shape, as well as it goes for this shape, as well as it goes for this shape. This is in terms of one word is used, that is called wheeling of shaft. So you could go and in Google and you can also search for it. But the good thing is that I will be coming with this factor. We'll understand in this factor wheeling of shaft in the coming classes. Now what happened is, this makes us understand that if a body is in high RPM or high motion or in a motion, there can be a structural changes which can make the body to fatigue. Fatigue means nothing but a broken or fracture. So if this is in high RPM, maximum RPM, this will turn to this type of deformation, that is a curve deformation. When the curve deformation or the bending stress will be maximum, this will fail. So the thing is that you can't encounter a body or encounter a calculation in a single manner. You have to go for several steps and several things. Learn in the coming classes, in today's coming classes. Now this thing can be explained in terms of sinusoidal waves or cosidal waves. That depends on how you are loading. So for shaft is a cosidal waves, because it starts with maximum value and ends with a minimum value. So this is the cosidal waves what you can see in a shaft when it is rotating. The shaft can be anything, like the shaft, the transmission from the gearbox to your wheel axle. That complete term is connected with a transmission shaft. That also a shaft. So everything is a shaft. Everything which transfer a rod which transfer motion from one point to another motion is termed as shaft. So this type of shaft expresses this type of cosidal graphs. So let us go back next to what happens. Now Yeah, as you could observe in many of most of your objects, like most of the objects is not sharp pointed. Let it be your wall of your home, or let it be your laptop edges. None of the edges is made sharp. Why? Because we think that if it's made sharp, it could hurt us. That is nothing but it's very bad for our body, bad, because it could cut our body. No, it's not the only reason of it. The most important reason of it is, if you ask a carpenter regarding this, most of the carpenter can't say that why it is done so. You can't. If you ask a person who makes the concrete buildings, they also don't know why it is made, why the concrete pillars or everything is not made exactly square, why the edges are always round off. Why? There must be some reason. The reason is stress concentration. Now, if there is a pointed surface, let it be any object. So what happens is, if the stress comes over here, if the stress works over here, or the stress over here, this will break. That means there will be a crack formation. That means a result to a complete deformation. So to avoid it, we use a curve. Now, why, you may ask me, why curve? Why shall I use a curve? Yeah, I could use other things also. Yeah, you could use a fillet also. But I'll come in the next, in other day, how, in what purpose I can use fillet, what purpose I can use chamfer also, in what purpose I will use chamfer, and what purpose I will be using fillet. Fillet is nothing but changing this pointed surface to a curvature mode. Now, why it is so important? Because why curve? Why not other things? The most important thing, that the most stable structure in the entire universe is a round. A circle. Do you know that this is nothing but it looks like a zero, invented in India. Most of we know that zero is invented in India. That was not only a number, that is a significant figure for our engineering science also. So what happens, it made us explain that a round object is much more stable than any other objects in the entire world. Now let me come to one thing. Have you heard of an aircraft, as it's shown in your body, in your screen, that Airbus A380, as you can see, the aircraft, not only there are 3 aircraft showing, you could see A380, Boeing 787 or 737 Max, as well as A350. There are most what the aircraft I'm showing on your screen. You could see the aircraft body is made up of carbon fibers. Now the carbon fiber patterning is done as a honeycomb structure. You may ask me, why honeycomb structure? Why I'm talking about honeycomb structure? I was talking about round. I went back to a honeycomb structure. Why? The reason behind is why B is having a honeycomb structure, because if a bee the bee's home, that is I don't remember the actual name of this thing, the honeycomb maze, the honeycomb maze, if it has been created like this in a square, this is nothing but they are generating a risk at which it could break. There will be a risk where it could break, because it's in a rectangular manner. So they can't make it round. It's not possible. So what they did, they made it in a hexagonal way. The structure of bee maze is hexagonal way. That means hexagon is near to a circle. What makes you understand that they knew about importance of a round objects? That means if a nature knows about the round object, our Earth is a round, our solar system, where we rotate about Earth, it's also an elliptical object, elliptical or a round, like a round. You can say round, but it's in elliptical path. So everything is round. So what comes back to the object, that round is the most stable structure, in the entire universe. So turning from a body from a edge-like surface, a pointed edge-like surface, to a round edge surface is much more profitable, much more safety in every perception. Okay, this is called a stress concentration in a simple word. Now this is what happens if there is a this pointed like object. That means there is a maximum force applying on it. There is a chance of breaking. That means there will be a strain which will lead to a stress. So what happens? There will be a maximum stress concentration. The stress concentration will increase. So to avoid the stress concentration, less stress concentration, we always employ a round like edges or round objects. Okay. As you can see, there are some of the methods what causes the round, like as you can see, the corrosion effects. Corrosion also happens due to this poor surface finish, localization, and everything. This is what variation of material properties, everything. That is the additional thing. And what I told you is the design part, what we learn in our class, okay, in a coming class. And this is the method how we can do, as it is written that by using holes in a tension member, or by drilling or notching, fillet and radius. This is what I told you. There's fillet radius, that is this one. Okay, taper sections or round like thread members, or there are nothing. Now many of the way. Now this is how we reduce or increase the stress concentration. Now let us go to the stress, fluctuating stress, what I told you. Now the fluctuating stress is divided in three parts. In terms of, since we could take it in terms of graphical manner, we could go for this one: fluctuating stress, repeated stress, and reverse stress. Okay. This is the stress. It's fluctuating stress is, the mean stress is always minimum. There is always a minimum stress acting on a body. Minimum stress in fluctuating stress, and mean stress will always work on the body. That means there will be a minimum stress. The minimum stress will not be a zero. That means if a body is having a minimum stress 0, that means, like you could see over here, that will be a repeated stress. So that the fluctuating stress has been divided in three, the fluctuating or fatigue stress, you may say, in three different parts. A body could differ, it could fail in while a body is subjected to fluctuating stress, or it may also go down due to a repeated stress, or it may also go down for repeated stress also. Now this is what happening if a body is under minimum amount of stress. This is these three are idle curve. This is not a practical curve. This is only for understanding your purpose. This is not your practical curve for your kind information. So the fluctuating stress will be this one. This fluctuating, they will be having a minimum stress, and there will be as well as a maximum stress. Now for repeated stress, there will be no minimum stress. The minimum stress will be diminished over here, as you can see. Okay, and there will be some amount of maximum stress. Okay, but the mean stress sigma m will still persist over here. Let's go to the reverse stress. In reverse stress, this will be in negative. This can go to negative. The minimum stress could be a negative, and the mean stress will be at 0. So these are the three differences of fluctuating, repeated, and reverse stress. Okay. Next, endurance limit and cumulative damage of fatigue. Now endurance limit is the maximum cycle object can take till its failure. Like for example, maximum cycle. What do you mean maximum cycle? Let me make you understand. In terms of a chalk, not a chalk. Let it be any pencil. So if you bring a pencil and you apply a gentle pressure or gentle force on the object, it will break. It took to break the pencil, divide the pencil in two halves in 2 months. It took 2 months to divide it. So the endurance limit of the body will be the last stress, the last stress at which, or the last stress at which it broke off. Okay, this will be the endurance stress. And the endurance stress, it can also be, this can also be in other way around. The endurance stress can be also this also, where you bought the pencil and you broke at that moment only. That would be also an endurance stress. By applying a force at once, you could break an object in applying a force at once, or you could break in an object applying nth time of forces. Okay, so the complete cycle is termed as endurance stress. Okay. For example, well, I hope I'll give you one more example. Let us understand with okay. Let us understand with the pen cap. The pen cap, what we get near our college, as you know that we have a very big market of our stationaries, of education stationaries near our college. So let us buy one just 3 rupees pen, that is few cents, a pen of few cents. So we bought the pen and we thought we will break the pen in one day. And one other guy thought to break the pen in 15 days. What the people did, what the boy A did, is he broke the pen A in one day with maximum pressure, maximum force applied. And the boy B, what he did, he gave cumulative forces. He gave repeated forces every day, and in the 15th day, on the 15th last day of the force applied by him, broke the pen in 2 halves. So the endurance limit is not, so the pen broke for the first time also after 15 days also. Okay, so now get the point. The stress before the pen broke is termed as endurance stress or endurance limit. It can be in the first cycle at once, or it can be after 15 days also. Okay, this is what endurance limit. Now what is cumulative damage of the in fatigue? That means, let us consider an aircraft. There are millions of parts in an aircraft. So an aircraft million parts, that is starting from nut, bolts, washer, aircraft engine parts, wings, etc, 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 etc. So what happens is the body always goes through a lot of stresses in entire length of its journey. So what it does, the one bolt can break, 2 bolt can break, 3 bolt can break. That means the cumulative breaking, or the cumulative failure of objects. So how a designer says that the age of an aircraft is 30 years, where this aircraft age is 25 years, so and so, there is some measures of it. What is the simplest way to do this is, they start with the failures of the objects in a mathematical way. They find out the time needed to fail of each and every object, and they calculate it, and they find out a cumulative damage cycle. That is, cycle means cycle in terms of days, in terms of number of takeoff and landing, in terms of of days of service period, months of service period, years of service period. So that gives them a average age at which it can work. So it is not only for aircraft, it is also for anything which is designed by a designer. That is also for your mobile switches, mobile locks, lock and unlock switches, volume switches in every sector. In laptop, it's in your keys, in this keyboard keys, everywhere. Okay, so there are three scientists came up with three problems. They told that if a body is under tensile stress, you could go for three types of designing. Okay, the scientist name is Gerber, Goodman and Soderberg. They did rigorous number of experiments and they gave one theory that if you design in this curve, in following this curve, that is a curve which starts from endurance stress and end to ultimate stress. So you will be finding a safety design criteria. So it was given by the Gerber. If you follow this curve, that is Gerber gave this curve. So what he told, that if you follow this curve, you in this curve. But in this curve you can find, if you follow this curve matters, and in short, in other way around, as you can see, this is a curve. That means the equation of the curve, by following the equation of the curve, if you design an object, the object will be have maximum workability or it will be safe. But he mentioned some there was some star point. The star point was that don't just remember that don't use these points or these coordinates, because if you use these coordinates as a term of your designing coordinates or designing curves, there may be certain failures. So in the next time Goodman came up, Goodman told that you could also design a safety design by using these straight line equations. Okay, that is the linearized equations. Fine. Then Soderberg came up and Soderberg told that you could also design a based solution in terms of elastic region, where by using this singular in linearized line. So what happened? Let us understand in a simple way, not making it in a havoc. So as I know, sigma and strain. Now this is the stress working, and this is the strain working. Fine. So this is the elastic limit and this is the plastic limit. So Gerber and Goodman, G plus G, work over here, and Soderberg work over here. That means Soderberg equations and everything is valid till this one. So Soderberg told that always follow the linearized curve, that is till proportional limit. That means yield stress till yield stress, that is elastic limit. You could use till elastic limit, but elasticity of an object. That means he told that the entire safety of the body depends on the elasticity of the body. Now Gerber told no, that you could go for the ultimate stress also. Okay, so ultimate stress, what will happen? That means he told that use this curve as your reference for designing a object. Now Goodman came up and told, no my dear, I can't use this one. I will use a simple line from here to here, or rather I will delete it, pointer, eraser. Let me change the color, that would be fine for you. In color, yeah. So Gerber came up, the person over here, he came up, he told that there will be a straight line equation from yield from your endurance stress to this one. Okay, endurance is nothing but this one, this part. Okay, fine. So the Gerber and Goodman, the Goodman told the Goodman statement was, no, dear my dear friends, you have to design it an object or design any mechanical or structural objects in terms of this straight line. This is not straight line actually, but in terms of this straight line from this point to this point. So Goodman was stick to the position of this in this position in a straight line equations, and Gerber was in a curved line equations or an arc equations, and Soderberg was in an in a straight line equation but in elastic region, but these two were in plastic region. That means if there is a deformation in an object, that will be complete deformation, you can't revive it. But in terms of Soderberg, you could revive it because you are in a plastic region. So it is validated for ductile and brittle material, but Gerber and Goodman has some problems. All doesn't false, the equations doesn't clear up every ductile and brittle material criteria, because here comes a big catastrophic problem. Okay, now unwind. Now, so Goodman didn't. Goodman was very fine. He told her, no, I'll find out the other way around. So he came up with a new thing, which is nothing but his. It's termed as his modified Goodman diagram, where he changed his entire thing to YT, that is yield stress. At last he came to yield stress, whereas he was in the first term he was at the ultimate stress. That means he was acting on the plastic region, but at the last but not the least he came to the elastic region, that is in the yield stress. So these two equations, that means he came over here. So to wind up in today's scenario of designing formula or agenda, we use modified Goodman diagram and your Soderberg Goodman diagram. So these are the objects. So this will start a study in the coming classes, how the mathematical works, and I will be giving you the total thing, because it's an estimation of fluctuating stress. You could actually estimate how much fluctuating stress is working. This is all the data, as you can see the graphs over here, here, and the formulations of this is the stress concentration formulation. So everything has been accumulated or characterized by ASM, American Society of Mechanical Engineers. So they gave us everything and we have to follow this. You could take this in your exams and you could solve it. Okay, in coming class we will see these things, as well as SNR curve, that is signal to noise ratio curve, where how the graph increases and what is endurance stress, what is ultimate stress, and how it actually engineer could understand and on body without the complete data sets. So this is what for today. In next class we will learn in this week itself. In the next video will come on the Saturday evening. So Saturday evening you will get the video of this complete things. So let me in short, let me tell you this most important thing, but very easiest part, SNR curve. This is you could heard from the radio physics, your radio physics students, or the students who are doing electronics engineering in your college, or IT or computer science. They know they are also electrical engineering. They know about about signal to noise ratio, but they doesn't know that mechanical also have this one, as well as chemical engineers also have this one in terms of machine design. The mechanical engineering as well as civil, they also use this one curves. Why? Because as well as civil chemical as well as polymeric they also use it sometimes in few points. Now where does they use? That comes everything related to a structure. Okay, so why? Because SNR curve is a single line curve or single line structure, which and makes you understand whether the object is very good in to stable to hold the device or not, or stable the device or not. That means in another way around, Asana curve, it is very impossible for a person, for engineers to understand the complete entire body, whether it's this part is working or not, to gather all the data. So they can check the Asana curve of the pet of the objects over here, or the parts of the here. They could actually get an idea where the part life cycle has ended up or not. They could understand over here. So for example, for chemical engineering, it happens like you have a compressed fluid inside a body, where inside a cylinder, where you have to compress it. You have compressed it. You have to know till how many days you kept it compressed, till the cylinder gets ripped off, or there are certain changes on the cylinder. So this makes you help to understand, so to make a plant in a safety way. Okay, so I'll be getting you in Saturday. Till then, be at home. Oh, but first study well. So study once more, study twice, study thrice, and ask me questions of the module 1, complete module 1 till this one, and I'll answer you in the coming Saturday class. Okay, till then, have a nice day.